Yeah, it is. I love the fact that you keep that in your office there.
Yeah. I have to go work. Right?
That's great. Okay, so we're 1 minute over, so we'll go ahead and get started. Thank you everyone for joining. Today is April 16th, if you're checking the dates, and that would make it Thursday of this week. Very difficult to keep track of days during the given conditions that we're all
Absolutely.
in. But yes, it is Thursday, April 16th. We actually have a pretty packed agenda, so I'm gonna jump right in. First off, I wanted to discuss the 1.6 release timelines. Here, I can go ahead and share. Let me share my screen here so that you can see all of this. There we go. Can you guys see my browser? You should be able to.
Yeah. Yep.
Okay, so the 1.6 release milestones, just wanted to keep everyone up to date on where we are and what the plan is. Currently, we're on track with the 1.6 release. We're currently in the execution phase, so everyone should be aware of that. But we're quickly coming up on completing and getting the build readiness and starting the stabilization, the release portion of our 1.6 release. The reason why I bring this up, because we do have a sign-up sheet, a community testing sign-up sheet, and this is getting ready for day one as well as day two. If you saw on the release here, day one is coming up towards the end of this month. So April 29th, which might seem like a long ways away, but it really isn't. So just wanted to bring everyone's attention to that. We do have the 1.6 community testing sign-up sheet. It's open, ready for people to start signing up. Just take a look at the getting started page. It'll tell you how to go about signing up for that. Another thing we wanted to bring to everyone's attention is that we are coming up on, I guess, arguably the middle of the spring. It's coming into April, but it's going to be coming up into May and June and into more of the summertime aspects where we get a number of interns within our organization. And given that this is an intern season, it is going to be a little bit different given the current conditions with the COVID-19. But we do believe that there's going to be a large influx of interns. So this is good overall for the project. And what we would like to do is get from the community areas that you would like to see some attention or focus or additional work. If there are any areas that you would like to see from a community standpoint, please start raising those issues now. Just go ahead and create Git issues so that we can prioritize those, we can review those, and as these interns start to come on board, we may be using some of those ideas for assignments for interns. So it's a great opportunity, especially if you've got like a little pet project that you'd like to see done here and there hasn't been enough commitment or enough people to actually do it. We may have some additional interns that can come on and start doing some of this work. So get those issues raised and get them up there so that we can start prioritizing them. All right. So what I would like to do for the bulk of this meeting is to really turn it over. We've got two special guests with us today to go over some additional material, which I think most of you will find pretty exciting and extremely helpful in the direction and strategy of where we're going with the Istio project. First up is Christian. Hopefully everyone knows Christian from the Istio community from Solo.io. Christian, you want to show us some of the new multi-cluster support and some of the Service Mesh Hub work that you've been doing. So I'll turn it over to you to take everyone through it.
Thank you. Let me share screen. Oh, when you're done sharing.
Drop that for you. There you go.
There we go. All right. You should be able to see my screen. I've changed the resolution for those of you that are on smaller screens. And so what we're going to talk about today is setting up and managing multiple clusters or you have Istio deployed. And specifically where you have this replicated control plane model, where you have each cluster basically has its own control plane. And there's many reasons and pros and cons for doing the various scenarios, but this, what I'm going to show today is going to be focused on this. We at Solo have been working on an open source project called Service Mesh Hub. Service Mesh Hub, and the goal behind it is to be a management plane to simplify managing multiple clusters of Istio or a service mesh in general. From both a how do you bootstrap and register and discover all of the components that are running, to federating shared root for identity, and then treating the cluster as one unified single, or treating all of the meshes, individual meshes, as one single unified virtual mesh, and then the API that we've written on top of that. So let me just show you. Before I do, I just want to point out that on our YouTube, I've recorded, just as of last night, a 4-part deeper dive into what this stuff is actually doing. So definitely check out the Solo YouTube. What I'm going to show here is a little bit of an abbreviated demo. Just be respectful of the time here. So the first thing that we're going to see here, and this is a live demo. This is it self-types for me. Some of you may have seen my demos. I like to have these scripts because otherwise a lot of typing in front of people can get mistyped. So here we see we have Istio 1.5 installed on cluster 1. And we also have an Istio 1.5 installed on cluster 2. We have book info, at least some components of it, deployed onto cluster 1. We have product page and the normal book info demo with version 1 and version 2 of reviews. On cluster 2, we have fewer of those components. We have version 3 of the reviews, and we have the rating service. So that's how we have 2 clusters and different components and services on each cluster. So the first thing we're going to do is meshctl install. So we're going to install the Service Mesh Hub. All that comes up. If you come back here to the GitHub project and click down here on docs, these are work in progress, by the way. Should have some updates to them very shortly. But nevertheless, getting started, installing Service Mesh Hub, and these sort of basic docs are here, so you can follow along yourself. So we've installed Service Mesh Hub. Let's take a look at the components that make up Service Mesh Hub. Not too many components that are in charge of running the networking components and driving the control planes of each of the clusters, and the discovery component, which we'll be taking a look at here.
This is on a 3rd cluster?
So this happens to be deployed like this. So we have cluster 1 and cluster 2. We see Istio and some of the workloads deployed. We have Service Mesh Hub, in this case, deployed on cluster 1. It could be deployed and is likely in a real scenario deployed on its own cluster. So if we do meshctl check, we can cross our fingers to make sure that everything is up correctly, and that's good. Now what we're going to do is register our cluster 1 and cluster 2. So we'll pass in the name. Basically, we're passing in a kubeconfig that allows it to connect up to these different clusters. We see that registration for cluster 1 is fine. Let's do the same thing with cluster 2. Well, even though Service Mesh Hub is running on cluster 1, we theoretically could have had that run remotely. And now that we have registered these clusters, if we do kubectl get Kubernetes clusters, it's a CRD that's part of Service Mesh Hub, we can see that those have been registered. And if we do get meshes, we should see that it's discovered that there are Istio service mesh workloads running on those different clusters. In fact, oh, that's the longer term. That's the longer demo. I forgot this is the abbreviated one. I was going to go into more detail about that. All right, but so now we have these 2 different clusters. We've registered them. Let's see how to unify their root trust domains. So the first thing that we're going to look at is so we have mutual TLS enabled on both, but they both have different root trust domains. If I call from reviews to ratings on cluster 1, and I take a look at the mutual TLS certificate exchange that's happening there and the root of that chain, we see we have something UZK as the root on this cluster. If we look at the same call from reviews to ratings on cluster 2, we should see a different root because those are separate clusters as we installed them, and we didn't install them with a root trust. So we see them, they're different. Now what we're going to do with Service Mesh Hub tooling here is unify those two clusters and those two meshes. We're going to create this virtual mesh that defines things like, well, what is the root that we want to share between the two clusters? What mode of federation do we want? In this case, we're going to say permissive, which just means that we're going to enable service discovery for all of the services between the cluster. And we can fine tune that, but right now everything's going to be permissive. We're going to follow a shared trust, root trust model here, and we're not going to, at the moment, enable access control. And we'll group these two meshes here. And we, of course, could have more. So let's apply that to our management plane. And in this case, that's running on cluster 1. And now if we go back and take a look at it, we should see through the status, cross your fingers, all right, through the status fields that all of the various components to setting up this virtual mesh have been accepted and are correct. Now, as part of doing that, now what we've done by creating that virtual mesh is we've created a new root certificate, and then we've told the remote service meshes, the two different service meshes, go generate your own cert and key pair, create a certificate signing request, and the management plane will sign those certificates with the root CA. So a diagram very quickly of what that looked like. So on each mesh, we're creating the key, private key and certificate pair, and we're creating a certificate signing request. The Service Mesh Hub will then go sign those certificates using the root that we define. So let's take a look at that. If we get the secret on the management plane cluster, we should see that we end up with this root certificate. Let's just copy that real quick. It might come in handy later. And on the remote clusters, cluster 1 or cluster 2, we see that we've created this virtual mesh certificate signing request. And if we take a little bit closer look at that, we should see that here's our CSR and the status accepted. We can see the certificate and we can see the root as part of that chain. Now we're doing that because we don't want to transmit keys and so forth across the wire. So we're doing it on each of the meshes. So what we've done there then is take that cert and key pair and create the CA certs for Istio. So if you go to the Istio docs and look at how you change the CA, the root CA from Istio D, you see you have to create the CA certs. We did that on both clusters. And at the moment, for Istio to pick that up, we need to balance Istio D. This is something that we're working on Solar to fix. We'll contribute this up to Istio. And we'll do that on both clusters, cluster 1 and cluster 2. So it picks up their individual intermediate certificates and keys that have been signed by the root. And we'll give that a second to come alive. There we go. And we should see, I've done this on purpose. I've restarted the workload so that they pick up the new keys. Otherwise, it takes a little bit for that to happen. And now, those kind of look like they're running. Let's try it. Now, if we run that same command to inspect the certificates on cluster 1 between reviews and ratings, what we should see is that certificate chain, and then the root. This root ends with ERY. I happen to have that handy. Okay, so that looks good on cluster 1. If we do the same thing on cluster 2, we should see the same root And we do, ERY, which is what we see here. Now, so that's how we unify the identity for the meshes, and do that in a way that's secure. Now, once we have this virtual mesh, we can build an API on top of that to manage things like traffic routing and access control policies and so forth. I'll show this very, very quick. So as part of federating these meshes, like I said, we're creating the service entries so that the services across the meshes can see and talk with each other. If we look at any one of those particular, well, this is on cluster 2. If we look at any one of those particular service entries, well, I guess we won't. That's the longer version of the demo, sorry. But we can use this traffic policy resource to manage the traffic splits between the clusters. And because everything is unified at the trust domain, the traffic should flow across the clusters without any issues. So let's just do that real quick. We come here, localhost. And
you set the rates based on the number of instances, or?
Based on the request. So in this case, it just happened to be, we haven't actually applied it yet. I'm just showing it to you. This is a traffic policy that we will enforce in a second when I apply it, but I just want to show you what things look like right now. So on the product page, if we refresh a couple of times, we see that traffic will be load balanced between V1 and V2, which are running on cluster 1. But if we add this traffic policy, we should route 75% of that traffic, as we can see here, to cluster 2 and to reviews on cluster 2. So if I refresh here, we should see the red one 75% of the time, and we do. So that was just a quick, let me show you if you have this cluster federated now, what are the things that you can do with it? And you want to treat it like a single unified cluster, even though it's running on multiple different ones. And the last thing that I'll show is all of this gets driven into the Istio control plane eventually. So this is a Istio virtual service that we see here. So the management plane is controlling the control planes. And we've built some convenience tooling around what are the rules that are running in a particular cluster for a particular service. So you could have maybe multiple different traffic rules and fault injection and retry policies and so forth. And using some of the tooling here, we can very quickly see exactly what applies to those particular workloads. So I know I went over quite a bit there. I apologize, and I went a little fast. Like I said, check out Service Mesh Hub on GitHub. The docs walk through some of the stuff that I just did. And then lastly, on our YouTube, I created a playlist. Where is that? Playlists. Dive into Service Mesh Hub. Well, there's 3 other ones that go into a lot more detail than what I just did here. So thanks, Dan. Thanks, community, for, I don't know if there's time for questions, but I'm happy to take them.
Just real quick, I do have a question. So this model, did it focus on the replicated control plane with a single network? I assume it did.
That's the replicated control plane, or is this the service mesh? Yeah, the replicated control plane, and the traffic is going through from one cluster to the other one and it's going through the Istio gateway.
Okay, so it is using the
Yes.
the gateway. Okay.
Yes, exactly. Yes.
So in your setup during the federation aspect, you were giving the context of every one of your clusters to your Mesh Hub cluster?
That's correct. To the context for each of the clusters that we would like to register with the management plane. Yes.
Are there any security issues, doing that? Because one of the advantages of this replicated control plane approach, as it's docked right now, is that you don't have to give it the context. All it needs is the gateway address.
Yeah, but then somebody has to log in and create those service entries, and so someone is going to be the management plane. Either that's you or it's an automated system.
Gotcha.
Happy to discuss what security drawbacks you might consider there. Yeah, it could.
So Christian, I have a quick question. I assume you will have the same limitation as replicate control plane where you couldn't do cross-cluster routing among one single subset. For example, review version 1. Do you have any customer asking for that? Or is your primary customer more asking for, hey, I don't care about cross-cluster routing for the same subset as long as I can do cross-cluster routing among different subsets, which is what you showed.
I think so. The subsets within a particular destination rule for a single cluster, I don't believe those will span across clusters like you said. But what we did here in the demo is create we kind of did do, the subset routing to to the review service that was actually running version 3 of reviews in a different cluster. So, I mean, we can still build that abstraction out on top of this, but the functionality is still there.
So I guess to clarify on Lynn's question there, does this use the SNI based gateway routing that we added for cross cluster? Okay, cool.
Yes.
Yeah. So that it does do the full subsets as long as you have the same subsets defined in both clusters.
Okay.
Because of the way that we set up the SNI to do that SNI based routing at the gateway for cross cluster.
Okay,
Right,
very good.
Right, and I guess that's one of the challenges right now is that you've got to have some commonality of registration of services across all the replicated clusters. So if you have 2, if you have 3, it's got to have some commonality of replicated configuration of the services themselves.
Yeah, I mean, this is the fundamental problem with the replicate. So in general, we also recommend this replicated control plane deployment. The fundamental problem is that you don't have a unified identity domain for services, right? That is the fundamental shortcoming that you have to bridge in some meaningful way.
Exactly. But this is cool. Hey Christian, is this open source? Is this something that people can get their hands on?
Absolutely. So go to Solo.io and then /service mesh hub. So
Awesome.
Everything that I showed you here is open source and will stay open source.
Very, very cool.
The traffic policy CR, it creates a virtual service under the covers, like the remaps like the .local to the to the remote cluster address, basically.
That's correct.
Automates that.
And so, like I said, there's a lot more detail to that traffic policy API, and then there's another one, the access control API. If you come over here in API references on the docs, we go into more detail about that.
Yeah, because that's where kind of most of the magic is.
Yes.
It simplifies most of that for the user.
Yes, absolutely.
Very cool.
Like I said, we focused on an API that allows you to treat it as though it was one mesh, even though there might be 5 or 10 or more.
Any plans to push that back upstream or to push that to Istio?
Happy to talk about that. I think Edith is on, and maybe
I'm here, guys. Hi, can you hear me?
Yes.
Yeah, of course, we would love to talk. I mean, we're working very closely with Istio right now. We would love to help. We have anyway some features, one, like I think Ethan for my team just opened one bugs about the rotation of the cert, and we would love to contribute it. And there is a lot of other, I plan to talk to Louis to see how do you contribute it to Istio. But I mean, I would love to hear, and we're going to put a lot of resources to work on this.
Great.
And contributing whatever you guys want.
Awesome. Yeah, we will definitely take you up on that.
No worries. There's more cool stuff coming up, so.
Very, very, very nice. Thank you for taking us through this.
Thank you.
Was extremely helpful and very interesting. Now I'd like to move over to Mohammed to take us through WASM and the WebAssembly extensions.
Sure. Let me share my screen.
Oh, it's good to show you in face. Usually I see you in Slack.
Is that what?
We're not seeing it yet.
Yes. So if I switch my screen, do you guys see it or no?
Yep, we do see it.
Okay, perfect. So this is
yeah, there you go. If you can put it in presentation mode, that'd be great. Okay,
yes.
perfect.
Yes. So been kind of curious about WebAssembly and WASM for a while, and I went through a couple of weeks of looking at it. So I thought it will be useful for community to see what is the status of WASM in Istio, and essentially how we can get we can take advantage of WebAssembly in Istio. So I have a very short introduction, and then I will show a few examples of how to use WASM modules. And I start with essentially just using it with Envoy, which is kind of a little bit easier if you want to understand what's going on under the cover, and then show you how you can use it with Istio. So WebAssembly, as you guys probably know, it was designed essentially for extending what you could do in web platforms as a way of supplementing what was done through mainly JavaScript. WASM essentially is a pre-compiled, portable, cross-platform binary instruction set that you can run in a virtual machine. And we are talking about kind of stack-based virtual machines like V8 that browsers use. WASM is not a language itself, it's a target of compilations, and there are many, many languages that are, these days you can compile to WASM and then use your code with pretty good performance in your browser, and all major browsers support WebAssembly. So why are we interested? After WebAssembly was started, people started looking at other use cases for serverless operations, and some people thought that, oh, that would be a good way of extending network proxies. And Envoy has started supporting WASM. There is a bunch of PRs, some of which have been upstreamed and some of which are still in flight. In comparison with WASM, we used to have and still have Lua extensions in Envoy that we can use to extend the code. Obviously, WASM now has a much larger community, is actively maintained, and that is another way of extending Envoy and therefore Istio. So let's have a look at how we can use WASM. The main project that kind of started adding the capability to a network proxies is called Proxy WASM, and the goal is to support running WebAssembly in different virtual machines in different proxies. The main target has been Envoy as the proxy, but there is a proof of concept for the Apache proxy as well. The goal has been to have a low-level API, and then on top of that, a higher-level API where different languages can easily be ported and supported for producing the WASM binaries. Right now, there are runtimes in the Proxy WASM project for C++, Rust, and assembly script. And I will look at the simpler one, the C++ SDK. I think looking at the Proxy WASM project may be the easiest way of getting your hand dirty if you want to start looking at WebAssembly modules. They follow a very kind of model similar to what Envoy uses, use single-threaded, everything is single-threaded, everything is done through callbacks and registering functions between the VM and the proxy. And in order to accomplish anything, you essentially need to implement two classes, a root context and a context, and override the existing methods that exist for these two functions, and then register them, and you're good to go. So with that said, let's have a look at a simple example that I have from the Proxy WASM project. This is the source of the C++ code, and it has a example root context that override just one function, and then the example context. That is the main context that is used. For each stream, for each request, a context gets created. The root context can be used for the same plugin and for multiple requests. So as you can see here, a bunch of these functions have been overwritten. Very simple stuff. As you can see, the main thing that we can see in the response, the output of this module when we run it, is that here we are going to add a header and replace another header. This is what we do. So the rest are logging the existing headers or log for request and response. So writing the code, you write it in C++. I need to kind of mention that you register these two contexts that we use, the example context and example root context. And that's about it. You get calls when, for example, there is a request, you get a call on request headers, then you have functions to access the header, modify them, manipulate them. And this is your source code. The next step would be compiling this into a WASM binary. So if I go back, again, if you want to get a little bit more of the details, you can use what is recommended in the proxy WASM directory, GitHub repo. There is a WASM SDK image that you can use, and that makes the compilation and building of the WASM binary easy. And essentially, the building would be as easy as putting your code into a directory, passing it through the WASM SDK image, and then essentially calling a build script. So I have here, I hope I can make it a little bit bigger. I don't have fancy colors. So we have a HTTP filter. The wasm.cc is the code, this is all you need to do to build it, build the WASM module. So I have a simple make file that I need to make. This is the make file, right? And the WASM C++ code. And I'm using a WASM SDK image v2.1, which is I have built. So as instructed in the repo, you can follow that. The first time, if you use just WASM SDK version 2, there will be some time for building the libraries and all that. Now, those are all built in. I had a snapshot of built, and I use it, and it gets compiled very quickly. So this WASM module, that let me delete it first and do it one more time. Build it.
Mohammed, while you're doing that, there is a question in the chat here asking whether or not there are other hooks or callbacks other than on request header and on response header.
Yes, there are a bunch of calls. There are also calls for accessing the payload directly for network filters. And there are calls for going out to another external service using HTTP or gRPC. So these are all documented. I will kind of show that very quickly. So this is compiled. Right now we have a WASM binary, right? And then for starting, just testing, I think it is maybe, at least in my opinion, wiser to just start with Envoy itself, not get involved with Istio, because that complicates things. I will go through how you can use this with Istio as well. But here I have a Envoy YAML file for a static, essentially, configuration. that refers to, there is a HTTP filter that runs on a V8 VM, and it has essentially has to have. I'm sorry. Can you say it again? Or maybe there was a.
I think somebody was off of mute.
Yeah. So as long as you have access to this file, this is the WASM file. If you look at it, I will use a Docker Compose. If you look at it, Docker Compose, I'm copying my wasm.wasm to this file, right? So all it takes to just test this thing would be Docker Compose up. And I have a lot of debug statements here. And you can access 18,000, and you get the example body. That's a static kind of web server built into the Envoy right now we are using. And here you can see the headers and everything, and you can see the two headers that it added or manipulated. So it's just like that. The way that you essentially have hooks for certain events, you get control of the system. Essentially, you can run your code in the virtual machine, and then there are ways of getting back the results into the proxy. And that's a simple example of doing that. This here, we are changing the headers. I delete that, stop that. If I go back to my slides, in addition to the simple HTTP filter, there is an example that I am using the root context. I show you, and then a couple of more examples. So let's see. I have put everything in different directories for myself. So here is another, again, a simple WASM file. Let's see what happens. Docker Compose up. I have already compiled it. And let's access the server. We saw the response for that. Just do this. So now the new headers, I'm just using the root context. So the context itself is created for each request. But the idea is that in the proxy WASM that you can have hierarchy of context that different streams can share, and possibly different filters. So now I am essentially using a root context, even though each time I get a, each time I get a new context, I'm using the root context to store this number that I'm incrementing one by one, right? So if I show you the code, it's very simple again. Instead of HTTP filter, let's go to HTTP filter with root access here. This is the one. This is that was the old code. Now I have just a simple variable in the root context, and for each request I get a new context, but while I am processing the message, I refer to what I have stored in root, and that's why I get a different number each time, and then I increment that counter. So there are ways of passing information through these contexts between streams, and you can also have multiple kind of filters like HTTP filters and log filters in the same binary WASM module. They can exchange information again through this common context. Does that make sense? Or I'm just talking too much. I'm just going to show this one more time. As you can see, the new header is now 2. If I do this, the new header is now 3, and so on and so forth. So that's another feature that in the design of proxy WASM has been built in. I believe some of it is still ongoing and in terms of how this thing will work, but for the most part, the basic stuff works. So the other thing is that right now, the filters that I showed you in the way that the WASM module is being accessed, we use a file. And that kind of complicates things that you have to pass that file into your pod when it runs. This is, again, Envoy has the capability to refer to a file remotely through a URI. If I look at the YAML file here, instead of using a file, I am using a URI. And for this example, again, in my Docker Compose, I start a web server myself. So very simple, it just serves this file. If we look at Docker Compose file, you can see that I have Nginx running as my web server. And I'm not passing the WASM binary file anymore. So that should also work. Again, we have now 2 Docker. And again, the same kind of changes of headers and so on and so forth. Right, simple enough. Anything else I have here to show is that there is a network filter you can build. Similarly, you can look at the network filter code and essentially act on the stream of bytes that you are seeing for your connections. Sorry for changing the windows too many times. So let's go to the network filter and look at some other functions that are accessible. So now this is another set of, again, all these are part of the context, but you can essentially rewrite them on downstream data, on upstream data, and downstream connection close, and so on and so forth. And while the project proxy WASM has been going on with the runtimes for C++, Rust, and assembly script, there has been a work done. I have a reference in my slides that I will show you later that supports Go. This is again another example, but in this example, we are going to use HTTP call to access an outside server. Here, the file is, again, a Go file this time. Imagine a little bit different. Here, I believe we are just using the context. Let me go to that directory, if I can. Go example, HTTP out. And main.go. Here, again, there is the context. We have on HTTP request headers. Things are being changed. Here on HTTP request, we make a HTTP call. And then we process the response on the HTTP call response. So there are limited number of functions that are available as part of the API, the things that you can use. So if I look at my README file, this is how you build it. Simple. Of course, you have to have TinyGo, and again, this builds a WASM file, and I think similarly we can have compose up. So in this particular case, for each request, we go outside to get a UIUD, just calculate the cache for it, and based on the cache, we either reject the request or allow it, right? So here is a 403. If I try it, hopefully at some point you will get a 200. Again, this is just to show the capability of calling some other service to get a response and then act on that response. So randomly now we are accepting or rejecting the request. So these are the examples that you can do, right? And to make sure that I give credit, this is where the proxy WASM support for Go is. It's not part of proxy WASM, and I think it's still in the works, but it works at the basic level at least. All the test functions go through and work fine. So what about Istio? If you're interested in using WASM for Istio, what do we need to do? At the end of the day, it's as simple as creating an envoy filter that you have to, that's a Istio resource, and you have to insert that filter at the correct place in your filter chain. And you have to have a WASM binary somewhere that your proxy can have access to. And that brings me to WASME project from Solo.io that have automated, they have automated almost all of these steps. That's how I got started trying to see how I can use WASM with Istio. I will go through some examples that you're using WASME. You can create a directory that has all the scaffolding you need for building. Then you can build your image, your binary WASM file, and then you can upload it to a hub called WebAssembly Hub that maintains all the WASM binaries, and then WASME creates the filter for you, and underneath this WASME, as of now, I think, you can correct me if that has changed, WASME runs a daemon set, and on each node in your cluster caches the images that you're accessing, and then by mounting a volume, it allows your proxy to access those images. I've seen the PR to make it possible also to use the URI as opposed to using a local file for each proxy. I think in that PR, a couple of days ago, it still wasn't merged, but instead of having a daemon set, now you have just a service that essentially caches some of the stuff from the WebAssembly, but then you can essentially directly use a URI to get your WASM file. So that's a very easy way of using WASM modules. Again, this is the address for WASME project. So by doing a WASME in it, I'm going to go through it. You can create the directory that has all the files and you can make changes. Then there is WASM build. You build the WASM binary and then you can push it into the WASM WebAssembly hub. And then you can deploy your filter. Let's have a look how this is done. Should have a, oh, I'm here. This is, let's just stop this. Let me remove this new filter for a second. Remove. So again, I think I have already a README file here for myself. So creating a new folder is essentially as simple as that. So I have installed WASME. Again, in that website, you can find how to download and install it. It's just matter of seconds. I can init, and then I have a choice because WASMI is going to set up the files for me. I have a choice of choosing the language. I'm going to CPP. Here you have the choice of Istio or Glue, and then if all has gone right, you have the new filter, which has all the files, including a filter .cc that is essentially has the basic stuff in it, and you can go ahead and change it, or when you're comfortable, you can make this file from scratch yourself. Building it, again, it's a matter of just using a WASMI file, WASMI command, WASMI build. It takes a bit of time, so I'm not going to do that right here. It's as a matter of doing something like that, WASMI build, CPP, the current directory. You specify the name of the image you want to be created. And essentially the WASM module gets created, and then it gets pushed into the WebAssembly hub under the name and tag that you have provided. And then you can essentially push that image into the WebAssembly hub. And at the end of the day, you can do something similar to this, which I think I have done here. Essentially, I'm saying that what is my WASM binary? It's in WebAssembly hub. I pick a name for it. I can specify a namespace that I want this module to be applied to. Here I haven't, so it will be on the default namespace. So if I do, I'm running all this in a small cluster on IKS, kubectl get envoy filter. You can see these are the filters that were deployed last night when I was testing this. We are going to redo this again. Just I want to show you what is there. So as you can see, these filters get created for the pods that I had running in my default namespace. So some simple files, services, hello world, and the slip, right? And I want to also show you what is running in the WASMI namespace. And I believe this cluster has 3 nodes, and misspelled. So these are essentially the daemon set that is running and serving the, creating the volumes that each pod is now mounting and using to access the WASM binary, which is essentially kind of the main complication when you want to do this quickly. So I have this thing running, and I have a, again, I'm going to one of these sleep pods that I have. And this is, again, I'm running out of ideas, the headers that I have added. In this particular example, I am doing a little bit of modification of the header host. If you see, just for the sake of demonstration, I'm using HTTP bin, but you can see here that HTTP bin default is being used. So that's what the code is doing. If you want to have a quick look, that is what I'm going to, I changed the authority field in the header. So this is as simple as that. And then when you're done, you can, again, use WASMI. Let me be sure that I do it correctly. On deploy, if you remember, I used the name Banix2 as the name of my filter, and you can deploy. And as you can see, if you look at the pods, they get restarted now, this time without that filter them. Pretty soon we will have everything cleaned up. Just one last command that I'm going to show is that the deploy that I avoided the first time. Now, if you look at the Envoy filters, there are none. Do apply and deploy this filter again. As you can see, the filters got created. The pods again get restarted with the correct reference to the WASM binary. And the slip pod has changed the name. Let me just fix that.
No, just to let you know, Mohammed,
Yes.
got
So
about a couple minutes.
I'm done. As you can see, still things are happening. So I think for someone who wants to get started, probably WASME would be the easiest way of getting your hands dirty. The good thing is that it's still the beginning of the project, I would say. It's kind of young. You may run into bugs here and there. The good thing is that the solo people are, or people who are working on WASME are very responsive and fix the problem if there is any. So that's great.
Yeah,
and I think that's
Yuval from Solo here. I'm one of the authors of WASME. If you have any, feedback, come jump by our Slack. As Mohammed said, we're very responsive and would love to hear more.
Yes, and we also, I'm going to add to this that we're also working on more stuff coming up. So I think our job is to try to make it as simple as it can, and there is a lot of tooling around it that we're going to make in order to make it even easier.
And hopefully everyone has heard this before, but I'll echo it again. Using WASM is the strategic direction for building customized plugins into the Istio service mesh, primarily directly into Envoy versus the old style mixer adapters. So definitely an area that is worth exploring. Take a look at the WASM project, make it easier for you to create those plugins. It looks fairly easy. I know Mohammed's been doing it a while, so he makes it look easy. But hopefully picking it up is not terribly difficult for folks, especially with a project like WASM. Cool. Are there any, I'll open up the floor. I know we don't have a lot of time, but I'll open up the floor to any other questions or points that you would like to raise. Going once, going twice. All righty. Well, thank you, everyone. This session was recorded, so if you missed anything or you'd like to see it again, we will be posting this up onto the Istio channel on YouTube. Thanks again, and we'll be seeing you guys later in the community.
Thanks for hosting, Dan.
Thank you.
Yep, no problem. Thanks, everyone. Thanks, Christian and Mohammed.
Thank you.
Goodbye.